Welcome to video 3, and in this video we're going to be talking a little bit more about how to actually program the Arduino, but before we can do that I wanted to talk to you a bit more about the Arduino board itself. Specifically in this video we're going to be talking about digital pins, and the digital pins on the Arduino are located right over here on the board, and they're known as I/O pins, which stands for input and output. And so if the pins are an input, that means that they're receiving information from the outside world. And if they're an output, it means that they're putting values out to the outside world. And when we say that a pin is digital, that means that it can have only two values. And you might have heard these referred to as 0 and 1. That's kind of your basic binary numbers. But if a pin is held at 0 volts, it's said to be at a low voltage, and we'll see the term low used later on in the Arduino language. And if it's at 5 volts, it's said to be high voltage. So that applies for inputs and outputs, but for inputs it gets a little funny because there's actually a range around 0 that kind of gets rounded down to 0 volts, and there's a range around 5 volts that gets rounded up to 5 volts. But just remember that digital pins can only have one of those two values. They're either low voltage, which is 0 volts, or 5 volts, which is called high voltage. So now we're back in Arduino, and I'm going to talk to you a little bit more about how to actually program your Arduino board from scratch. But before we do that, I want to talk about why some of the words in our code here are different colors, like these orange words and these blue words here. When you see a word come up in a different color, that means it's something that's built into Arduino. So Arduino recognizes that word as something that's meaningful to it. So for example, pin mode is a function that we'll learn about here in a second. But if you want to find out what some of these different things that Arduino has built in are, I always go up here to Help and Reference. And when you open Reference, this is what you see. This is a list of all the built-in functions that Arduino has. So you can see it's a fairly long list, but this actually makes it really convenient to use the Arduino code, because if you forget what something does, you can come in here and find out real quickly, and it allows you to sort of see what other functions might be available that you didn't even know about before. So in our code, you might remember we had this pin mode here. So if we click on pin mode, open that up, then it gives us a bunch more information about this function. You can see we have the syntax, which is what you have to do to call this. So pin mode works on our digital pins, and we need to set the pin number that we want to use, and we want to set the mode, which is either going to be input or output, or this other mode, input pull-up, which we're not going to talk about right now. So typically they also give you a little example code down here, which should look familiar. This is our blink code. So again, this is a really handy way to get to know some of the different functions in Arduino. So before we get into talking about some of the individual details of this code, we're going to talk about what's known as syntax, and that'll apply to any code that you write in Arduino, or in most programming languages for that matter. And syntax is sort of the way that you have to present your code to the program so that it can make sense of your code. So in this example, syntax, or some examples of syntax, would be the curly brackets at the start and end of void setup here. This tells it where this function starts and ends. Another example of syntax is this semicolon that has to go after every line that isn't void loop up here. So just remember, when I first started writing code, I always forgot that semicolon, but you'll get an error when you try to upload it to your board if you do that. So always remember that semicolon at the end of lines. And another important example of syntax are these two slashes. These are known as comments. Now you can use comments for a couple of different things, but here they're used to provide instructions to you about what the code is doing. For example, it says we want to initialize the digital pin as an output, so we write this line here. Typically it's good coding practice to put a comment on almost every line, because especially after you walk away from a code for a period of time and come back to it, it can be very difficult to remember what all the individual commands were doing. So comments are a good habit to get into. You can also comment out multiple lines by using the /* and */. What these do is they comment everything out in between the top marker here and the bottom marker. So let's start diving into the code a little bit here, and we're going to go through it line by line really slow at first so that you can start to get a feel for some of the different elements of code. And some of these things we'll go over again in later videos, but I want to sort of take this example very slow. So the first line we have here says int LED equals 13, and this is the first example of a variable that we're going to see. Now a variable is something that holds a value inside of your code, and it's given a name. So here the variable name is LED, and the value it's given is 13. It's also an integer, which is this int, but don't worry too much about that for now. We're going to talk about that in a later video. But in this code, what's important is anywhere where we type LED, the code will insert the value 13. So this is really handy. Rather than having to type LED here, here, and here, or I should say rather than having to type 13 there, we can just type LED. And one of the advantages is that if in the future we decide that we want to have our LED on pin 12 instead of pin 13, we only have to change it in one place here rather than in all three places below. So variables can be extremely useful for that reason, and we'll also use them for other things down the line. But for right now, I just need you to understand that that's what this line of code is doing. The next thing we run into is this pin mode command here, and again you can go to help reference if you forget what any of these functions are. But pin mode sets up the digital pin and tells the Arduino whether you're going to use that pin as an input or an output. So you need to tell it what pin we're talking about, which is 13 again, and what you want that pin to do. And in this case we want it to be an output because we want to light up an LED, right? We want to interact with the outside world, so we're outputting this information. So let's go down to void loop, and again this is going to run over and over again as long as our Arduino has power on it. So the first line here is digital write. So what this does is this is going to put a digital value on that output pin that we defined before. So again we need to tell it which pin do we care about. We care about the pin LED, which is 13. And we want to write a high voltage. So this is going to put 5 volts on that pin, and it says we want to do that and then wait, which is delay here, for 1000 milliseconds, or 1000 thousandths of a second, aka 1 second. Then we want to digital write low to turn that LED off by making the voltage on that pin 0 volts. And then we have to wait for another 1000 seconds. And this will run over and over again. So hopefully this is starting to make some sense, and as an exercise to try to play around with these digital write functions, what I want you to do is to try to close out of this code here and see if you can reproduce what was needed to create this blink code, and then try to load it onto your Arduino.